So in part 2, we're going to start solving equations or expressions, evaluating them. So in example 2, the very first thing says, let's find the exact value of each expression. It's log base 2 of 16. So what we're really doing here is just getting a feel for these expressions, how to write them, how to interpret them. In the next section, we'll deal with some log properties, which are going to give us some shortcuts. But until we understand what we're doing, those shortcuts won't make any sense. So log base 2 of 16. So what I'm going to do is I'm going to come in and set equal to x. So, and that's just to get a handle on it. So what we're really trying to find is x. Then we're going to switch forms. So that means that 2 to the x is equal to 16. And now we're right back where we were in the previous section. We need to make the bases into the same number. So we're going to manipulate bases. The bases. Again, our goal is to make them both into the same number. 2 is prime, so we'll keep the 2. And we can write 16 as 2 to the 4th power. And then we'll set the exponents equal. So again, the second half of this whole thing should make sense because we did this in the previous section. So we know that x is equal to 4. So we know that log base 2 of 16 is going to be equal to 4. And now it should make sense if you switch forms mentally in your head. 2 to the 4th power, sure enough, is 16. And that's how we'll evaluate these expressions. For now, again, we're going to develop some shortcuts. But okay, part B of example 2 says log base 3 of 1 over 27. So they want me to evaluate that. Again, I'm going to set it equal to x. So I now have 3 to the x, that's this base raised to that power, is equal to 1 over 27. Well, we know that 27 is 3 to the 3rd, and now I need to bring it up. So that would be 3 to the x is equal to 3 to the negative 3rd. That's moving the 3 to the numerator by making the exponent negative. So we know that x is equal to negative 3. So what we're really saying is log base 3 of 1 over 27 is equal to negative 3. One more of this type. Part C says, how about log base 5 of the square root of 5? So again, I'll set it equal to x. So that I have 5 to the x is equal to the square root of 5. We're then going to remember that radicals. So if I have the nth root, I'm going to do an a here so we don't get confused with all our x's. So as a note, the nth root of a is equal to a to the 1 over n power. If you had the nth root of a to the m, that would be a to the m over n power. So same thing here. This would be 5 to the x because that's a square root. We'll write that as 5 to the 1/2 power. Then we can set the exponents equal. So x equals 1/2. So what we're saying is that log base 5 of the square root of 5 is equal to 1/2. Done. And there we've evaluated some expressions. And again, notice that in every single case, what we did is switched forms. So if you get stuck in a logarithm, switch the forms and see if you can work from there. Now we're going to solve some equations involving logarithms. So this is example 3. On part A, it asks us to find log base 3 of x is equal to 3. Now we're solving for x. So this time x is already built into the expression. Okay, well, again, I can't do anything with that logarithm. I don't know what to do with it. So let's just switch forms. So we're going to take the base of 3. We're going to go across the equal sign and pick up the negative 3 and set it equal to x. So again, that's that base going in this direction. Well, 3 to the negative 3 is 1 over 3 cubed, which is 1 over 27. So the answer to the question is 1 over 27. So log base 3 of x equal to negative 3 means that x is 1 over 27. This is kind of the inverse of the one we just did in example 2b. We just put the variable in a different spot. On part B of example 3, it's asking us to solve log base 4 of 2x plus 5, and that's going to be equal to 2. Okay, so again, can't do anything. X is trapped inside the logarithm. So we're going to have to come in and switch forms. So we're going to have 4 to the second power is equal to 2x plus 5. So again, that's the base. Raised to that power is equal to this. Well, 4 squared root is 16, 2x plus 5. From there, that's a nice linear equation. We can solve that. 2x is equal to 11, and x will be equal to 11. Example C says log base x of 5 is equal to 4. So same exact. Notice this time the variable x is sitting there as a base. That's okay, it doesn't matter. We can still switch forms. So this would be x to the 4th power is equal to 5. Again, there's our base going around. So x to the 4th power equals 5. Well, we need to solve for x. So we're just going to come in and take the 4th root of both sides. So we're going to have x is equal to the 4th root of 5. And normally when we do the square rooting or the even rooting, we would add in a plus or minus. We don't this time because remember, this is the base. The base has to be positive. So no plus or minus here at all. And finally, part D. Part D says we have log base 36 of the 4th root of 6. And that's equal to x. Well, that's very similar to the problems we were working in example 2. We're going to switch forms. So this would be the base of 36 raised to the x is equal to the 4th root of 6. And now we're going to manipulate a little bit on both sides. So 36 is 6 squared. So this becomes 6 to the 2x. This side becomes 6 to the 1. So we'll have 2x is equal to 1/4. So we're going to multiply both sides by 1/2. And we get that 2 out of there. And we get x is equal to 1/8. There it is. X is equal to 1/8. Okay, well, now that we've done several different log expressions and several different log equations, we need to point out something pretty important here. If you write just the word log with a base, but don't put anything in there, it's wrong because the log is an operator. It is something you do to a number or an expression. So when you write just log with nothing after it, it means you're not really understanding what the logarithm is. So that would be similar to just writing the square root with nothing on the inside. The square root is an operator. So it's something you do to a number. Okay. What you do on the inside, whatever you call this, is referred to as the argument. So that inside has a name. It's called the argument, just like the inside of a radical is called the radicand. So that inside bit of the logarithm is called the argument. Okay, so to get a handle on solving, what we're going to do is we're going to go graph in the next part.